Today, Roger Curtis has agreed to do a presentation. It's in fact as part of a mini series for the GIA. We're very grateful for that. Roger Curtis is a chartered building surveyor with extensive experience with historic buildings and is a technical research manager at Historic Environment Scotland. And I just hand over to you, Roger, and just take it away. Thank you.
Great. Well, thank you for the introduction and the opportunity to present to the Architects Association. This is a slightly modified presentation I gave to the Aberdeen chapter back in the autumn, with a few additional thoughts and considerations. I'll be about 40 minutes or so, and I've titled it Principles and Practice in Refurbishment of Historic and Traditional Buildings, because I kind of want you guys to just get a feeling for what's inside my head, as well as some of the detail of how we do it. I've got far too many slides, so I may in places rattle forward quickly, because what I really want you to do is to get sort of access to some of the written and the published material, where one can dwell on this in a little bit more detail. So Roger Curtis, my name, chartered building surveyor, and at HES. In previous times, obviously based up in Edinburgh now, but working very differently for now. And but we've carried on with a good range of background work, mainly catching up with the delayed publication of a whole lot of things. So in fact, we're as busy as ever and dealing with a lot of issues and getting the knowledge out there. So in terms of today, then, introduction, principles, thinking, a note on condition, build priorities, what order do we look at this work in, and trying to focus a little bit on HES pilots and specifically the Holyrood Park Lodge building in Edinburgh. Some of the measures, I won't describe all of them, but giving you an idea of what the work on site looked like. I will spend time looking at the EPC and RD-SAP, and there may be questions on that, as increasingly that quite obviously is the key to a lot of this in terms of output. I will focus on some HES publications, and then an introduction to a wider European Union funded project of historic NZEB, where we're sharing information and knowledge of historic building retrofit across Europe. So when we're sort of approaching this question, where does one start really? What's the guiding framework in which I've been operating? Certainly, obviously, the good condition question is sort of self-evident for this audience, but I think with climate change and more rainfall, particularly on the west of Scotland, it's a more of a sort of insidious dampness in well, certainly the higher levels of the building, particularly chimneys and gable ends and things, which really needs to be addressed as part of a wider consideration of the building. I use the word technical compatibility with the fabric, which is really, for the most part, about the vapor open side of the argument, capillary active and vapor open materials. I would suggest work is kept simple, both in terms of plant and equipment, but also in terms of the actual makeup of the measures. We are very keen on the upgrade of existing fabric, so adding to the structure, not really removing very much. This is a low skip scenario, and I will labour the point on embodied carbon and exactly do the ends justify the means. Increasingly, the focus will be on the carbon of what you're doing, as well as the operational energy which you are saving, which was really the previous metric. I'm interested in durability and resilience. Something with a 10-year guarantee is of very little interest to me. I'm thinking of something that goes into a building and frankly just stays there. It is of a material quality that can coexist with the fabric until big strategic things need to happen. I will also focus on ventilation and indoor air quality, and the COVID situation has thrown this into particularly sharp light in terms of how we address air circulation and ventilation within buildings of all ages, and embodied carbon, as I touched on. So in terms of priorities then, my feeling is floors. In many refurbishments, timber floors have taken quite a lot of attrition over the years. You're putting new services in, or you're rewiring, so the access to the floor is well in process anyway. Possibly some legacy defects with soft joist ends or other things. And we contend that if your feet are cold, whatever you do elsewhere in the building will not make you thermally comfortable. Particularly concrete floors. So a pre-1984 concrete floor is uninsulated, is almost definitely in direct contact with the wet earth underneath it, and is a very considerable cold draw. Roof insulation, as you might expect, whether that's a warm or a cold roof configuration. Windows in all the hierarchy of improvements that I think we all have to some extent worked out over the years. And not that long ago, windows were very contentious in traditional buildings, particularly within the listed context. But I would argue there is a reasonable range of interventions on traditional fenestration to address certain shortcomings, yet also allow for consideration of architectural presentation and historic fabric. Obviously, openings are more than just windows, so we've got doors and that side of the house, and wall insulation, which is low on the list really. It's not that it's not important, but in terms of the order which I do it, and we would argue that the nature of walls in Scotland, which are generally considerably thicker than in England, means that the intervention there can be more modest to get a respectable rate of return, and ventilation. And I better add that generally the wall work we've done has been mostly internal. I do accept there is a need to address EWI, and there's many ways and opportunities of achieving that with the Scottish architectural sort of typologies. It's just that we haven't actually managed, well, we haven't had the right building and the right project set up for that. But it is a very relevant area that I think is probably the next stage of this journey. So in terms of the range and the nature of the intervention, this is quite a busy slide. Don't feel you have to read it now, but an indicative traditional building, a very good drawing by John Gilbert. And we can see we've numbered areas of intervention, and really these are the areas that I'll be covering. Chimneys indicating really ventilation as much as anything else, roof slopes, glazing, doors, ground floor considerations, subfloor ventilation, and let's not forget the options with some aspect of renewables. And I won't go into renewables today. It's a huge topic and a very important one. Many interesting options which are coming onto the horizon for sort of policy encouragement and introduction, particularly considerations over various types of heat pump. So we try and angle everything in the, let's call it the cottage model, because we would contend that for most of Scotland's traditional building, the material palette is pretty much what you've got in front of us, mid to late 19th century, which is where we've more or less had our focus. I do accept there are many outliers to this, but this can be scaled up to a bigger building, or indeed yet further to a tenement with the same technological or the same suite of materials. And you can see some of the areas for intervention have been coloured. So we'll take a move through this landscape of this traditional or historic building typology. And a note on listing. Listed building consent exists to manage change in protected structures appropriately. It doesn't necessarily seek to prevent it. And most of what I'm describing has been done on listed buildings, or you could argue is to a certain degree compliant. depending on the specific features of the building itself. And specifically for the example of a window, if you've got historic crown glass in a full set dating from the 1790s, I would argue that is something to keep, and therefore your windows options would steer around that. But to put things in context of today, the image you've now got in front of you is Holyrood Park Lodge, category B listed, Gothic type building dating from 1858, part of the redevelopment of the Royal Park. And you can see Holyrood Palace hidden in the trees off to the right, and elements of the associated buildings, Abbey Strand and the Queen's Gallery through the tree on the left, with the Scottish Parliament pretty much dominating the entire scene, not seen in the image further across to the left. Category B listed, was empty for some years, only partially used, and I managed to get my hands on it for some, let's call it conservation appropriate retrofit, whereby we're looking at a range of measures that are moderately invasive and compatible with the status of a listed or listed building, and indeed a traditional building that might not be listed at all, but certainly in terms of its technology and the vapor movement and the general makeup of the intervention can get a similar approach. In order to allow a degree of scrutiny of the project, and also an understanding of the fabric and what the existing situation is, we spent quite a lot of money and time in doing pre and post intervention monitoring. This image shows one of the team from Archimetrics at the end of the project, coordinating the data gathering, firstly in the loft, and you can see the access hatch to that, and also in the solid wall, different thicknesses in the solid wall on the southwest elevation, and that's all part of the write-up that you can access through the links later on. So in terms of the measures then, and where we starting, and at the lodge, the floor was a pretty big intervention, to be honest. As I said, timber floors almost definitely in need of some form of repair and a chance to thermally upgrade. We used wood fibre board or similar. It could be a hemp board or some other compressed organic material, laid on runners between the joist. You can reuse probably 50 to 60% of the floorboards if you're careful and you're okay with relatively short lengths. On the concrete side, we didn't have concrete floors in the lodge, but it's definitely one to have pretty high on your list, I would suggest. And in fact, a lot of concrete floors were replacing a timber floor, and you may have the option to reinstate the timber or go for an insulated lime concrete. The lime concrete side is probably a separate discussion. We've done a couple of projects with it. It seemed to work very well. So for me, it's been a positive experience. This is the wood fibre boards laid down on runners on the cheeks of each of the floor joists, and then in this case, this is the new softwood timber floor going back down in what is now the shop in one side of the lodge on the ground floor. The other side of the lodge was the reclaimed timber and the corridor, which was actually taken away to be sanded as individual lengths and then put back down, and that worked rather well actually. And obviously the new timber was just a little softer than the older stuff, so it didn't take the varnish quite so well. This image is showing the relayed old timber in the exhibition side of the lodge, and lovely colour, went down pretty well. As I said, if we'd actually nudged the joiners to accept shorter lengths, we probably could have salvaged a little bit more. So that was the ground floor with the wood fibre. The wood fibre was I recall 150 mil thick, I'm fairly certain. And there's a little trap there because RD SAP only sees insulation in increments of 100 mil. So just something to consider when you're planning the thickness there. In terms of flagstone floors, I've put this in as an example, not that this is the lodge. So if you see the very vernacular approach to the flagstone floor on this image of a conservation job near Braemar on a category A listed vernacular croft house, this floor was dug out completely. The lime concrete was laid. Then the loops for the heating were set down in a mortar mix, and then these flagstones were pretty much laid back in their more or less nearly original positions. The armchair on the right in the unimproved building obviously wasn't there, but that area was completely damp, green, wet, ferns, all sorts of things. And drainage off the hill onto the back of the house was the reason for that. So quite a lot of digging and new drainage channels external to the building to address moisture levels in the floor. That room is as cozy as anything, and I'll come on to it later, but that plaster that you're looking at is an insulated lime plaster as well. And as I mentioned with windows, sometimes contentious, but I would suggest there's a good range of options now, from what is called a user modification by the building regulations, so blinds, roller blinds and curtains. Shutters are now recognised by the Scottish House Condition Survey, but I understand they're not part of, they're not seen by the building warrant process or by RDSAP. So they're not in the formal mix for energy, but they will certainly help you a lot. Ditto insulated shutters, but thermally for client comfort they work. Familiar options with storm glazing to the external part of the window or secondary glazing to the internal face. And secondary glazing has moved on quite a bit in the last 10 years or so, and a range of options there. Probably the ones to watch are the ones that prevent the shutters operating, because they apply very proud of the staff beads. There's a good number of proprietary systems that are located within the staff beads, and also some lighter, easier magnetic fitted ones, where the client is able to remove the secondary glazing panes during the summer months, or for cleaning and other purposes. I think certainly in the last 15 years or so, various glazing has come onto the market, be it slim profile, be it laminate, be it vacuum panes. And I think that landscape is probably going to continue to evolve. And I think in a conservation scenario, gives architects and designers many more options with respect to glazing work. There is a consideration about slim profile IGUs. Are they able to comply with all 6 parts of the British standard? Some do and some don't. And I think that is a materials choice for the designer, much as you do with any other material that you are specifying for your client. We can, of course, go for new timber windows, depending on the context, with individual units, which would be our sort of natural preference. And again, the listed building consent element will come in here, but I think we've got an option for quite a good bit of conservation gain, where inappropriate glazing that may be architecturally unsuitable and technically near the end of its life, that we can replace that with what you might call a traditionally configured fenestration detail, but with some improved elements within it. I think that's where the glazing technology that I've mentioned will be able to help. In terms of listed consent and conservation areas, the last bullet there where I've mentioned timber windows with surface applied astragals, as you call it, is an option too. Local authorities have different views on this, as indeed do I, but I'd consider this possibly a better option to allow the use of competitively priced timber fenestration, as opposed to another material, a less suitable material being used. And if we're able to keep timber window manufacture at scale, you are able to keep it as a realistic option for most people in Scotland. There is a risk if we hold out the standard too high, it becomes very, very niche, and then you start running out of suppliers and the price goes up, etc. So there's definitely considerations as to the range of interventions and how you go with the windows. Just by way of example, this is the slim profile unit that went into Holyrood Park Lodge. This is from Ravensby Glass in Dundee, and was put into the existing sashes, sorry, the existing casements that you can see behind, which in the case of the Holyrood Park Lodge dated from about 1995 and were in very good condition to a more or less appropriate pattern for the building, and they've worked very well. So these were not old, they were effectively modern, that just had to have the checks increased a little bit to take the thicker unit. There are a couple of other examples which I can show you here. We did draft stripping as well on the casements. Due to building settlement, that was probably not as effective as it could have been, and I think that's an area for just quite careful detailing and consideration with the contractor as to what's really going to work if your window is no longer the rectangle that it once was. In terms of glazing options, this is a new traditional pattern sash and case assembly, including a new shutter on a category B listed building in Stromness in Orkney. There were 7 of these done on the seaward elevation as part of what you might call conservation gain in a CARS scheme. The originals were a 1980s turn and tilt type arrangement, so it had lost its historic glazing, and indeed all the internal timber had gone too. So we had a pretty clear hand here, and this seemed to work very well. In terms of roof, we look at it from a warm or cold roof option, depending on what the client wants and what sort of conditions they want to have in the attic. As you might expect, we've gone for a more organic range, and within that there are several materials. Sheep's wool has been around for quite a long time, thermally very good, very easy to lay, quite forgiving in terms of the stiffness of the material. It can accommodate turns and things. There are considerations on proofing against insect attack and how long that proofing lasts. So this, a bit like the glazing selection of products, this is a matter for the designer to sort of be comfortable with the materials that are put in front of them and how long they're going to last. For our part, we've used a lot of wood fibre board and also a hemp board, rigid or semi-rigid, which seem to work very well, and Holyrood Lodge has an awful lot of it. Laid across the joists of the ceiling to give a cold roof, or between the rafters for a warm roof. There are quite a few different roof pitches at the lodge, so one side of it is configured for a cold roof, and the southeastern side is configured for a warm roof, and I'll come on to the details of the monitoring around that particular bit in a minute. My understanding is there is a company to make hemp bats in Scotland, which are in the sort of final stages of product development for manufacturing in Scotland, which will be good, because if I was talking about embodied carbon and the road miles that go with this material, at the moment it seems to come from Austria or Switzerland. So we have a material that I'm technically happy with, that the environmental product declaration for the material shows it is lower carbon than other material made from oil feedstock, but we can't hide from the fact that it's still transported quite a long way over the road network. So ideally, we're looking at supporting, encouraging the use of such materials that are actually made here in Scotland. So again, part of Scottish Government's Energy Efficient Scotland scheme is that it prompts many areas of the supply chain in skills and in materials that encourage a more local approach to manufacture and obviously installation too. And the final bullet there refers to, I've got air gaps there, that is between the top of the insulation in the warm roof and the underside of the sarking, where we did a few trials to see what function that gap actually had in the hydrothermal performance of the insulation. This is what it looks like looking up through the loft hatch. Work still in progress in the meeting room of the lodge, and you're looking up to the installer and the wood fibre laid between the rafters, held with the runners, as you can see just by the chap's ear, and also off to the left. And that has got a sort of 30-40 mil gap underneath the sarking with it. A couple of panels. We push that hard up tight against the sarking and have been monitoring the difference. Testing is still sort of ongoing, really. We're in our final season now, but really what it's showing is the overall conditions did not substantially change, but the line was much smoother because you didn't have the air movement, and therefore less range on some of the humidity levels, all of which are reasonably respectably low. That is an early part of the test. So the later tests essentially show it very similar, but a little bit of seasonal variation. And that can be looked at in more detail in the refurbishment case study. Capturing other traditional building elements, and having been to a project where I found a skip full of doors in a low carbon refurbishment, I felt this needed addressed, as indeed many other architects have done previously. But we can't ignore the fact that most traditional doors are a single skin on a much thicker framework, but you've got options for material between the framing. And this is where aerogel comes in, which I suspect I will find out has a very high carbon tail indeed. But for very small areas where you need high performance and you don't have the thickness to get what you want, what you need, I would suggest it has a place. So 10, 12 mil thick, enclosed behind the boards, so a 6 mil plywood, a much lower cost measure than a new door. I paid £1,200 for an aerogel from new manufactured door. The bill for this work was in the low 200s for this one. And it looks a little bit like this. So here you have the original 19th century door to the porch on the northwest of the building. And you can see the unpainted plywood, which is enclosing the aerogel layer underneath that, which is about, as I said, 12 mil thick, but will compress down to 10. The door handle framework arrangement, and the board has gone on the top and just awaiting painting, really. There's another example, again, a sort of double door from the 1860s. Worth remembering that spending time and money on the insulation of the door is fine, but you will need to address some of the air gaps, and you can see a bit of a crack between these two here, which a cushion strip can address. On this door, just going back, the main area of air ingress was getting a reasonably airtight-ish junction between the masonry, the check, and the timber of the door, and that's probably that was quite a challenge here. In terms of walls, achieving respectable U-value reduction in stone walls in Scotland has been a topic that's been around for a long time. A whole raft of measures there, because our starting point is conservation and retention of existing material and existing linings, both from a heritage point of view, but also we would contend from an embodied carbon and landfill waste stream question. We tend to try and hold what we have if it's contemporary with the building. And if you calculate with a degree of care, most 600mm walls have a U value calculated pre-intervention U value of around 1.2. exactly getting to that level of accuracy is almost impossible, because you can't model it exactly, but that seems to be the pre-intervention value that we get by calculation and by measurement. So we have a degree of agreement with that. As I've indicated, vapor open materials are in our script, and we've tried several blown types behind existing lath and plaster, where you generally will get a sort of 0.6 to 0.7 post-intervention U value, which as far as building standards division goes is acceptable, and is set as an upper default, but no worse than that. There is an opportunity for thin materials onto existing linings. There is various aerogel boards that have been developed now. We haven't tried them, but that might be an option if you wanted to. And we've had good results with insulated lime plaster internally, where in a vernacular context, a small cottage or the croft house that I showed you, in fact, all you're doing is using a slightly modified version of what they used originally. So in this case, that was an 80 millimeters layer, in fact, put on in 2 layers of hemp lime insulation. And as I said, we've not tried EWI. I do think there's a huge potential for it for plain gable ends of tenements, rear elevations of tenements and houses, where often the traditional finish for subordinate elevations, particularly when they were rubble built, was to be plastered with some form of external render anyway. Fashions in the 20th century meant that a lot of that has come off to the detriment of the stone condition and the pointing, and also, I would argue, to the architectural presentation, as you're essentially changing the language slightly. That's a different topic, but we are looking at opportunities for EWI on a gable end of a Glasgow tenement, for example, or an Edinburgh one, or indeed any other larger building in Scotland. Just to remind ourselves of the basic wall makeup, these are 2 illustrations that John Gilbert did for us to show that the composition of a mass wall. And while there is an element of randomness to that, and it's easy to draw perfect walls, I would contend that that is a reasonable representation of a wall with a lath and plaster internal lining, or indeed an internal plastered on the hard. And the right-hand one is showing an external render as well. This is what it looked like at Holyrood Park Lodge. We did this, the joiners did this panel that you can open up. So bottom right is the original plaster finish, which essentially is still all around the room with the paper taken off. Top right is the internal face of the stone wall. Top left is the blown cellulose. We've taken away the laths so that you can actually see it. And then bottom left is the laths with the blown cellulose behind it, closed in with a perspex sheet, and the doors to sort of just give a bit of texture and finish when you're using the room as a meeting room. So that's our sort of viewing point for the materials and how this particular measure looks. There are other materials that can be put in. A bonded bead is done, and there are various foam types that we have tried as well, which work respectably well. Again, the limit here is the width of that space you're filling is literally probably 35 mil, maybe less. So there is a limit to how much you can get that U value down. This is the process of it. Tends to be quite quick. It is more disruptive than you realize, but by the time you've made holes, removed skirtings, blocked that opening from the skirting into the solum below, it is not a quick fix really, but it is a measure that can be considered. This is the insulated lime hemp plaster made up on site at a building in Dunbar that we've been sponsoring the reinstatement of over a number of years. But by way of context, 5 years ago, this building was roofless. The debris was up to the the top of that broom handle, every item of waste and rubbish in there. That corner cupboard was still clinging to the wall, so we've sort of put that back and get it fixed in time. The intermediate floor did not exist, so what you're looking at is brand new. But the main thing to take away from this is that the nature of that insulated lime plaster for internal wall insulation. And if you're in quite a strong reconstruction or restoration piece of work, it may be that fits well with the finish of the internal linings or the internal room finish. And the building is not quite fully in use yet, but we do want to hopefully test this in situ to get a feeling for how effective that material was. And then just drawing to a close now, ventilation. Air tightness must be balanced with the needs of the occupants. We know from measurements we get high humidity, high relative humidity and high CO2 very, very quickly if you do not consider appropriate ventilation in your refurbishment. We have more volatile organic compounds in the materials we put in our buildings now, and the infection spread is linked to poor ventilation, and some of the material coming out of the COVID evidence base is suggesting that. I would suggest in a conservation situation with an old building or an existing building, you utilize floor vents, hearths, cupolas in stairwells and landings are all existing ventilation features that have been designed to give a modest but continuous background air exchange. Climate change is also giving us higher temperatures, particularly in urban heat islands, and the temperature in attics and upper rooms in tenements is now getting beyond what is considered acceptable and indeed safe, particularly for some vulnerable groups. I would say that for ventilation in older buildings, this is a good news story because a lot of these features are already there if they haven't been removed in later refurbishments. And I would suggest our task is to perhaps near Cooper in Fife, and the hearth there, which is probably dating from about 1906 or so, that hood over the hearth is pushed in, which means that flue is closed off. So when that is when the hearth was not in use, they could reduce the drafts from that. I'm not suggesting everyone lights fires now, but you can still utilize your hearth and your flue as passive ventilation for a building or a traditional building or even a fairly modern one which has a flue. Just while you're here, this is a National Trust property. The floor was relaid and a sheep's wool was put between the joists. The ceiling had fallen in through water damage, and that was a reinstated lath and plaster ceiling. And the paintwork here was clay paint put onto the flat plaster, and there was a blown material in behind the existing lath. That square mirror is actually a radiant panel, which is a nice way of giving thermal comfort in an area where you may have higher than usual air movements. The air pressure test on this building was actually very, very good, and the secondary glazing that you can just see left and right was almost too good. And if you slammed the door to this room too hard, the magnets gave on the strip and it dislodged it. So the room was actually reasonably airtight by modern standards. This is the hall porch in the lodge, and I'm showing you this not so much for the insulation between the roof rafters that you can see there, but the quarter light on the rope up high up, and this is to show that to address heating and ventilation, you take new air in the bottom of the building and you push breathed air or foul air or hot air from a point higher up. So in the lodge, we adjusted the existing quarter light here, and we deliberately went for a clunky, unbreakable mechanical intervention that could be operated by the user. There was nothing to break, no batteries to go wrong, and no service engineer was needed to address this. In truth, the lodge does not overheat, but we wanted to demonstrate this principle and this little feature. Same again with the hearth in the upstairs meeting room at the lodge. We reinstated this hearth, not necessarily because it actively needed it, but because we wanted to show that the ventilation in a meeting room could be positively affected, improved by the use of just an open hearth with a hinged damper that you can see in the open position there. And just out of interest, that dark rectangle above it is another radiant panel, which is the sort of second or third generation technology from the one in the Cooper cottage that I showed you. And that gave a really nice feeling to those in the room on a meeting, but also allowed you to have the window and the flue moving the air around to a level that kept everyone comfortable. In a former school in Oban, we sponsored the reinstatement of these roofline ventilators, which are a very standard pattern from the late 19th century. You see it all over Scotland and indeed elsewhere. And it is sad that for many years, these have been routinely removed. This building was completed just before the COVID episode kicked in, and in the post-COVID recovery of spring and summer last year, this building, with its high ceilings, adequate ventilation, including this passive system, was the only COVID compliant building in Oban, and they had plenty of requests for utilisation. So there is a positive story to reinstating aspects of traditional or historic buildings, and the indoor air quality argument will get stronger as we appreciate some of the lessons of COVID and how to limit infection, both of COVID and indeed other variants that we understand will be coming our way. This ad from the 1890s shows Boyle's device, and part of the reason they're common in Scotland, or were, is that the Boyle's business was based in Glasgow, a second generation company, and they were active in this sector until the 1920s. So what you're seeing there is pretty much what Page Park, as it happened, were able to redesign and specify for the Roos Ridge. The trials on that building will start once COVID lifts, and we can get in there, get some crowds in there, measure the difference between what happens when these are operating, or indeed when they've been closed off, or actually removed altogether. So this is all about passive ventilation, utilizing existing traditional design features. So these aren't just architectural follies. These have an operational purpose, which I think is going to become quite important in maintaining human health in buildings, as well as internal environments that are good for the building and its contents. Just a quick note on the EPC. You'll be aware of most of this, but targets regarding Band D for the private rented sector and indeed the social housing sector has also got similar targets. I think with EPCs, a lot of people go for the low cost option. That means the surveyor, the assessor, does not have long to input the data, and that means a lot of assumptions are generally made. Because the assessor can only enter measures that person can see, or that the owner can evidence, often many measures aren't evidenced or not seen and therefore aren't entered. For the Holyrood Park Lodge work, we deliberately spent a lot of money on the EPC. We said to that assessor, we showed him the health and safety file, we said, this is what we've done, this is where it is, here are the photographs, here's the roof, here's the loft ladder access. We showed everything, and it was all counted up carefully. And it took us 2 iterations, but we are now at a band C, and I'd suggest that a band C for a category B listed Victorian building, fully in the hard to treat category, is not a bad result. But oddly enough, getting to band C wasn't an entirely straightforward process, because two things put me down. We lost points. Secondary electric heating will lose you 6 or more SAT points. So I'm afraid those radiant heaters that I showed you in the meeting room are no longer there, because if they were, we wouldn't have achieved the band C. We also understand through a little bit of early modelling that with the renewables, which could be an air source heat pump, that a band B is possible. So more on that later. And here's the certificate recently completed in this March. I'll draw attention to the refurbishment case study, which sits on the Historic Environment Scotland website and talks through some of the processes and a bit more detail on what I've said. For those of you who say, well, okay, that's fine for one building, so what? Yeah, that's just one off, and you could give it lots of attention. This is a survey of 18 properties done by HES 2010 to 2017, with a series of observations and feedback on the thermal benefits and some of the longer term assessments post interventions. Its weakness is that it didn't have EPCs in it. So it's really a technical document about the building fabric, hydrothermal matters and issues. I've not dwelt on the hydrothermal issues, and I'm sure there'll be questions on it. We've recently received some a report from Heriot-Watt University on getting hydrothermal parameters or properties for Scottish traditional building materials, specifically certain type quicklime or traditional lime mortar, and a modest selection of masonry, sandstones and other stone types. So these could be put into WUFI for a more informed hydrothermal modelling scenario. That's a different topic and a different lecture, but just be aware there'll be a technical paper with that information coming out probably the next month or two. Short Guide 1 is still the sort of, let's call it, recommended schedule or list or range of interventions, most of which I've described in this presentation. So that's the one to go for. It was issued in 2016. We've got a new one coming out. It's not substantially different in terms of measures. There's a few extra things in there, but it frames it in a much wider carbon and sustainability context, because we're not just about dealing with operational energy, we're dealing about retention of resources, minimizing toxic outcomes, maximizing carbon retention, and indoor air quality and human and building health. We need to think about training. That's training of those who are going to deliver the interventions, and we have an SVQ level 3 qualification, which we hope to be pushing out in spring/early summer in Stirling. It's a 2-day course, properly accredited, and as 2035 mentions it as recommended training for the delivery of insulation measures to traditional buildings. This is our flyer, which please look at in your leisure. Still emerging in terms of exact details, but it gives you a feeling for where we're going in terms of getting a cohort of installers that you can then instruct for your clients on thermal upgrade work. I'm really conscious of time now. This is the project that I mentioned, and the link here in the middle is the world's easiest sign up to our newsletter, where you'll get links and information on the assets of this task. Core to that is the online best practice database with about 200 projects all over Europe of thermal upgrade measures in traditional and historic buildings. The lodge is one of those. The category A listed cottage that I mentioned earlier is also on there, as well as an unlisted cottage in a social housing project from the mid-30s in Perth, which is operated by the Ganachie Trust. don't all write all that down now. You can get that with the copy that will get sent around later. So I think I better stop there, and very happy to take questions.
Thank you, Roger. That was super interesting and very well presented. Thanks for that. And before I read out the questions from the chat, just to mention that we put a recording of this entire event on our website, so you can read all the links again from there. And also Roger will do another 2 presentations for us, one of which will be next week about climate change adaptation. So now chat question, hang on. First question from Tibor. Have you come across any challenges when insulating existing junctions between walls and floors, Roger?
There is definitely a modeled vulnerability there. We've not had any deleterious results there. I think partly because we've tried to focus on best building condition, and the fact that the traditional envelope, the masonry, the timber work is dry and in a good condition. I also think there's quite often a bit of conflation of defects where people see a rotted joist end and they give it a hygrothermal reason, whereas often it is the ground levels, the renders, the rainwater goods that are not working. So far we are comfortable with that within the typology that I've been describing.
Thank you. I just go on to the next question. With the windows at Holyrood Lodge, were these able to be reglazed in situ, or were they removed for refurbishment?
Good question. They were taken away. And I think it's one of those sort of project management decisions that the designer will get involved in. And I would strongly suggest you take the windows out, you board them up, you go back to the workshop. The joiners prefer doing it. You've got the security issue done. It's done in controlled conditions. You can paint them properly while they're in the workshop as well. So I'd suggest you take them away.
Makes sense. Next question from Callum. How can fire safety be ensured when using wood fiber or similar organic combustible insulation materials, particularly when dealing with larger renovation projects such as tenement refurbishment?
I think one has to draw a distinction between organic materials that will burn and organic materials that will support combustion. So if I pick up a piece of wood fiberboard and hold a lighter to it, a cigarette lighter to it, it'll char, but it won't burn. It won't support itself in its combustion. Sheep's wool will be slightly different, and it's a fair question. And preventing the spread of fire, particularly behind existing linings, I think might be a useful sort of positive of thermal work and also ensuring fire safety. So exactly where this comes in its fire rating, I think is still emerging. But certainly the blown cellulose, it cannot support fire itself because it can't spread through it, even though you and I know the newspaper will burn, but not when it's compacted like that.
Okay, thanks. Another question from Sarah. You commented on the positive feeling people had while using the room with the radiant panel, that's in the lodge, I think, then mentioned it was taken out to improve the EPC. Does this not highlight the contradictions in targets and actual performance, and how can we address this sort of issue?
This is an RD sapism, which I'm afraid is how it is set up. So I have no control over that. For the lodge, we knew that politically and for the sector, most people need to get the EPC right because that is how the energy standard is being monitored. Yes, but if I'd had a renewables in there, I think I probably would have got enough sat points that I could have kept the radiant panel, and that would sort of take a model whereby your air source heat pump or whatever it was maybe got you to a good background temperature, but not quite enough for thermal comfort when you're in the room, and that's where the radiant panel could come in as an option. So yeah, there's a sort of annoyance there, and yeah, I can't hide from that. That was, you know, that's what we had to do.
Yeah. And there's one last question from Elspeth. In multi-pane windows, I prefer individual thin panes with crown glass on external side, but do HES accept planted astragals?
The short answer is no, and we generally lie on the ground foaming at the mouth and wriggling. But our RIT is a narrow one. As you all know, a lot of work is completely off the radar, unlisted buildings anywhere, and I think in terms of giving people the options for unlisted buildings or not conservation areas, I think that's in scope for me. So I describe it, and if it fits, and it fits your wallet, and it fits your building, and it fits the planning situation that you are in or your client is in, I would suggest that's a good way of keeping traditional timber fenestration on the road. Otherwise, it just becomes a rich man's indulgence. But yes, personally, I want the authenticity, I want the realness of multi-pane. And if I had to take a laminate pane of glass to achieve that, I'll be quite happy for that. So a laminate pane will give you a U value of about 2.5. Obviously not nearly as good as 1.1, which other ones will give you. But you know, you make your balances. As the vacuum panes, which are brilliant, I think that's about 1.1, but they only have a minimum size. So beyond a big 6/6, it'll work for, but a more smaller vernacular building like that one in Dunbar I showed you, they wouldn't be able to do that.
Thank you. I think that's all the questions for now. That was super interesting. Again, thank you, Roger.
Well, thank you for the interest and the chance. Happy for emails and stuff. You know, folk might want to catch up on things. And I mean, I keep promising the new short guide will be out, but give me 2 months, we should have something which captures the spirit of carbon as well as the measures itself.
Yeah. That's great. Okay, so maybe we'll just close for now then. And as I said earlier, next week, same time, Roger will be with us again and talk about climate change adaptation, which is going to be equally interesting, I think.
It's all about those damp gables that you just can't keep dry and all that story. So yeah, no, really important one to chew over. Lots of different ideas, lots of different views, and many solutions possible. So it's a positive story, but a diverse one. Great.
Great. I'm looking forward to it.
Thanks, folks.
Thank you, Roger.
Bye. Cheers.
Bye, everyone.